We use these trigonometric ratios a lot to find angle measures if we are given side lengths, and this is how we do it. Very first thing again, we are going to write down our SOHCAHTOA. SOHCAHTOA. So if we're, for example, supposed to find, let's say we have to find the measure of angle A. So let's first identify what all our sides are in relation to A. Our hypotenuse is across from the right angle, as always. Our opposite side is across from angle A. This is the opposite side. And our adjacent side is the one that's right next to it, right here touching A. So to find the measure of angle A, we can do it three different ways. We can take the sine of angle A, and the sine of angle A is the opposite, in other words, BC over the hypotenuse, which is AB. We could use the cosine of angle A, which is the adjacent, in other words, AC over the hypotenuse AB, or we could use the tangent of A, which is the opposite over the adjacent, BC over AC. It really depends which sides we're given. So if the sine of angle A is the ratio of BC over AB, then A, or I'm going to write it as the measurement of angle A, is really the inverse of the ratio BC over AB. In other words, we have to do the inverse sign of that ratio to get our measurement. Inverse means we need to move the sine function to the other side, and the notation for inverse function here is sine to the negative 1, and the inverse sine of BC over AB is the same as the measurement of our angle A. And since we had set up also our cosine and our tangent for angle A, we could do it with either one of these the exact same way. We need to move the cosine to the other side, make it the inverse function, and the tangent as well. So the measurement of A is also the inverse cosine of AC over AB, or the inverse tangent of BC over AC. And again, if you're wondering why are we doing all these things, we don't necessarily always have to do all of them. We are using the ratio where we have both side lengths given. So a couple of things to note here. We are using inverse trig ratios for finding angle measurements. And when are we doing this? We are using it when we are given two side lengths, but we need to find an angle measurement. And the measurement of an acute angle, that is, of course, because the measurement of a 90-degree angle is 90 degrees, because it's a right angle. Duh. So then let's practice this with a few examples. And the key here to get the answer right is that the calculator must always be in degree mode. And how do we make sure of that? Let's look at that on our calculator. We have to and go into mode, and when we go mode, we can see to the fourth place down here we have something name of radian. That's actually highlighted right now, and that's not what we want. We want degree to be highlighted. So go over to the right, press enter, and now degree is highlighted and the calculator is in degree mode. You should probably write those keystrokes that you need in order to make the calculator turn into degree mode somewhere on the left margin of your node page. Again, you go into mode, then down 4 where you have radian and degree, make sure you go on degree and enter so it's highlighted. Okay, now our calculator is ready to go. So, angle A is an acute angle, and we're supposed to use the calculator to approximate the measure of angle A, and we're supposed to round to the nearest degree. So, the sine of A is 0.24. So, if we want to find the measurement of angle A, we have to move the sine to the other side. That makes it again become the inverse sine of 0.24, and that's exactly what we're going to put into our calculator now. And if you're wondering where the inverse sine is, it's the blue function above the sine button. So again, second, here is the inverse sine. Plug in our number, 0.24. Don't forget to close your parentheses, and enter has the answer for us. 13.8865 and so on. We were supposed to round it to the nearest degree. So the measurement of angle A is approximately 14 degrees. Do not forget your degrees sign here. Also make sure that you use the approximate symbol, not the equal symbol, if you don't want to lose any points. Okay, on to our next example. The tangent of A is 1.73. So the tangent has to be moved to the other side. For us to find the measurement of angle A, we have to calculate the inverse tangent of 1.73. Second tangent of 1.73. Close our parentheses, enter, and we get 59.97. So rounded, that will be approximately 60 degrees. And last but not least, using the cosine of angle A, which is 31 over 50, which still is in ratio form, that's fine too. So the measurement of angle A is equal to the inverse cosine of 31 over 50. And the inverse cosine of 31 over 50 is 51.68, or rounded to the nearest degree, 52 degrees. And there are our 3 degree measurements, and yes, you noticed this is of course supposed to be an approximate and not an equal sign. In our last example of the day, we are again going to put all these things together, find the acute angle measures in the right triangle, and round to the nearest degree. So it doesn't really matter where we start. We could start at angle R or angle M. I'm just going to choose to start at angle R. So let's identify our 3 sides. Our hypotenuse is over here. Our opposite side relative to R is NM, the side that doesn't touch it. And our adjacent side is Rn right here. Another way to think about the adjacent side is in the side name that always will have the name of the angle in it. The opposite side does not have the name of the angle in the side name. And before we can really start, we need to, of course, write down our SOHCAHTOA. SOHCAHTOA. So by now, I'm sure you know it already pretty well. And now let's look at our example. We're given two side lengths, and we're supposed to find an angle measure. So the question is, which one of our three ratios are we going to use? And the answer is fairly simple, but I'll write this down here as a reminder for us too. We have to use the two sides that we have. Okay, that is kind of obvious, but that's why we have three ratios, so we can use different ratios depending on which sides we have. In this case, we have the length of the adjacent side and the length of the hypotenuse. We don't have the opposite, so we can't use the sine, and we can't use TOA. The only thing we can use is CA, the cosine. So the cosine of angle R is equal to the adjacent, which is 5 over the hypotenuse, 5 over 13. And we can calculate that ratio, but we don't really need to, because what we want is the measurement of the angle. So the measurement of angle R is, after we have moved our cosine and turned it into the inverse function, the inverse cosine of 5 over 13. So let's use our calculator to find it. Inverse cosine of 5 divided by 13, close parentheses, and enter. And that means 67.38. Rounding it to the nearest degree, the measurement of angle R is approximately 67 degrees. Do not forget your degree sign. So we got angle R now, and now we need angle M. We could do this two different ways. We can now use a different ratio of our three trig ratios to find angle M, but why should we do so much work, right? Why don't we just remember, if we have a right angle in this triangle, that means that there's only 90 degrees left for the remaining two angles. And of those 90 degrees, we now already took 67 for angle R. That means there's only 23 degrees left for angle M. So the measurement of angle M is, and since our R was an approximation, we're also going to approximate this, approximately 23 degrees. And the problem is solved. Good for you guys. Okay, for our summary, I want you to use your own words to describe how to find the side of the right triangle we call the hypotenuse, and the sides called opposite and adjacent, in relation to an acute angle when we want to get started to calculate our trig ratios. That's it for today, and I will see you in class.